Hello, my name is Darren Thomas. I'm the Director of Educational Research Techniques. In this video, we're going to take a look at how to solve radical equations. So let's go ahead and begin. Now, a radical equation includes something called a radical. I'm sure that's not surprising for you, but let me see if I can give you an example of what we're going to do here. So imagine for a moment that we have the following. We have the square root of 3y plus 2, this is all under the square root, by the way, minus 5. The minus 5 is on the outside, and of course it equals 0. Now, a lot of the steps for completing this kind of an equation to solve it is similar to solving a regular equation. So the first thing we want to do is as follows. We want to, of course, add 5 to both sides. That's the first thing. We want to add, in other words, we want to isolate the radical. And so now we're left with 3y plus 2, I never make this long enough, equals 5. Now, this is where things depart from how we normally solve an equation from what you learned in basic algebra. What we want to do now is we want to square both sides. If we square both sides, we're able to remove the radical and then solve this as a regular equation. So I end up with the following. I square both sides, and I square this as well, and then I end up with 3y plus 2 equals 25. Now I just solve things like a regular equation. So I subtract 2 from both sides. I end up with 3y equals 23. I divide both sides by 3, and then I get my final answer, which is as follows. Y is going to equal 23 over 3, and we're done. So the main thing here for those of us who are new to this is pretty much found in this step right here, where you square both sides. That might be new for some of us. Let's go ahead and take a look at a second example now. In this example, we're just dealing with an answer that uses binomial squares. And by binomial squares, we're talking about the following, where you have A, wrong color here, excuse me, where you have as follows. So you have A plus B, and this is all squared, and then that equals, I'll put that down here, A squared plus 2AB plus B squared. And of course, if there's a minus sign here, there'll be a minus sign here as well. So either one, it depends on the situation. But now that I show you the theoretical aspect of it, let me show you how this looks in a practical way when you are trying to, of course, solve a radical equation. So here's what we're going to have here. This time we have the square root of y minus 2 plus 2 on the outside of the square root equals y. And so I'm sure that you're familiar with what we do next. First, we subtract 2 from both sides, and we end up with the square root of y minus 2, this is all in the parentheses, equals y minus 2. Then, of course, now we square root everything. So you square root, and then you square root right here. And now this right here, where I'm going to do this right here, is where we use the binomial square tool. And so when we use the binomial square tool, we end up with the following. Now, when we square this, on the left-hand side, the square root is canceled out. I've already mentioned that, so I have y minus 2. And then to the right of the equal sign, I'm going to use the binomial square tool to simplify this in a quick manner. So I end up with the following: y squared minus 4y plus 4. That's what I get. And so now you just do some basic algebraic stuff. I subtract y from both sides. Subtract y. I add 2 to both sides. So let's see here. Subtract y, add 2. And so I end up with the following. I end up with 0 on the left-hand side equals y squared minus 5y plus 6. Now, at this point, you just have to, use the AC method, if you will. And what you need is you need a number that when you add them together, it comes out to -5. And when you multiply them, it comes out to +6. And so, using my intuition here, I know that if I have negative 2 and negative 3, it'll work out. Negative 2 plus negative 3 will give me negative 5, and negative 2 times negative 3 will give me positive 6. Therefore, if I factor out, or if I simplify this using the AC method, I get the following. I get 0 equals y minus 3, y minus 2. This means that y can be one of two values. Y can equal positive 3 or positive 2. And you can see that essentially we're done at this point. So this is how you solve a radical equation when you are able to use the binomial square method. Now let's do one last one and conclude this video. In this example, we're looking at how to deal with exponents. And so let me show you what it looks like, and then I'll walk you through the example here. So this is what we have. We have 9x plus 9. All this is raised to the 4th power, like so. And then, of course, minus 2, and it equals 1. So this is what you do. When you have this kind of a situation, you raise everything you have there to the reciprocal of the fraction, if you will. So to make that nice and clear, let me just write this out for you. This will work at least in this situation. So I have 9x plus 9. That is raised to the 4th power. Now I'm going to raise everything to 4. That's what I'm doing here. Oh, but well, I forgot to do something before I do that. First thing I want to do is I want to take care of that minus 2. So I add 2 to both sides. And so now I can do my work, because let me show you what I'm going to do now. So now we have 9x plus 9 raised to the 4th power. And remember, we're going to raise to the 1/4, now raise to the 4th, equals 3. That's what we have here. And so essentially what happens is this: the 1/4 and the 4, they destroy each other. And so, and of course, whatever I do on the left side, I have to do on the right side. I forgot to mention that. So I also raise this to the 4th power. So when we simplify this, we get the following. We get 9x plus 9 equals 81. That's what we get. And so now we subtract 9 from both sides. This is just a regular equation now. Subtract 9, and we end up with 9x equals 72. If you divide both sides by 9, you will know that x will end up equaling 8. That's what's happening here. And so this is how this example works. Now the key thing here is that you must first move the constant, which in this situation was 2. You must remove that from the side with the what do you call it? The side with the expression on it. That's what you have to do first. That's very, very important. And then after you do that, you're able to continue to work. So also remember, maybe some people, maybe they don't think that this is a radical expression. 9x plus 9 to the 1/4, that's the same way as saying, let's see here. If you have to the 4th like this, and then 9x plus 9, it's the same thing. And so you have to know how to convert things back and forth. And when you do that, you will get this kind of an answer like this. And so before I conclude the video, let me explain what we've done, and then I'll wrap this up. So in this video, we were looking at how to solve radical equations. And so the primary thing here is that you want to first isolate the radical, and then you want to remove the radical by, square rooting it if it's square, squaring it if it's a square root, or cubing it if it's a cube, etc. And then you're able to solve appropriately using basic algebra ideas. Sometimes in unique situations you can use binomial squares. It depends on the situation, but we talked about that. And often you almost always have two solutions. Now sometimes one of the solutions will be extraneous. That was not covered in this video, but it's something you need to be aware of as you're trying to solve these type of expressions. And then lastly, we talked about how to deal with radical expressions, fourths or whatever, or thirds. And basically what you do is that you raise it to the reciprocal of the fractional exponent, if you will. That way you're able to cancel things out, of course, assuming you've already dealt with the constant. Again, I've made that mistake of leaving this part out. You must first, of course, deal with the constant here. So I had to add 2 to both sides. and then you raise everything to the fourth power because that's the reciprocal of 1/4. And whatever you do to the left-hand side, you must do to the right-hand side. From there, it's just a matter of doing basic algebra again to get the complete answer. So, I hope that this video was useful for you and you were able to understand what we were talking about and the complex ideas that we were dealing with. My name is Darren Thomas. I'm the Director of Educational Research Techniques. Take care.